Okay, in this lesson, we are going to learn about the unit of kilowatt hour and how to calculate it. These are the lesson objectives. Some prior knowledge. You need to know what is power, formula, and energy, and the electrical power formula. A common unit to measure the household or electricity used in the household is kilowatt hour. So as you can see, this is a kilowatt hour, and then this is a cost, and this will be the total cost. kWh means kilowatt hours, and it measures the amount of electrical energy used. Why isn't it a measure of power? As actually there's this kilowatt and watt is actually a unit for power. Recall that power equals to energy divided by time, and if we do a slight rearrangement of the formula by moving the time over, you'll find that energy is actually equal to power multiplied by time. For kilowatt hour, kilowatt is a unit for power and hour is a unit for time. If you follow the same structure, kilowatt multiplied by hour is actually the unit for energy. So kilowatt hour is the unit for energy, which is the amount of electrical energy used by household. How do we calculate kilowatt hour of an electrical device? We need two pieces of information. The power rating of the device in kilowatt. So this is just an example, LCD TV. And if you look very carefully, the power consumption is in watts. And the duration of usage of the device in hours. So maybe you watch this TV for 2 hours. Okay, simply just multiply these two values together. So let's do simple example 1. An electrical heater is rated at 1.5 kilowatt, is turned on for 2 hours. How much electrical energy they used in kilowatt hour? This one is very simple. You just simply 1.5 multiplied by 2 and it's 3.0 kilowatt hour. But take note that the unit for power must be in kilowatt and not in watts. The unit for time must be in hours. Use another example to illustrate this point. This time around, electrical iron that's rated at 600 watt is used for only 15 minutes. Calculate the amount of electrical energy used in kilowatt hour. So like I said, you must convert your units to kilowatt and hour respectively. So 600 watt is actually 0.6 kilowatt, and 15 minutes is of course 1/4 of an hour, which is 0.25. Then you can multiply them together, 0.6 multiplied by 0.25, which is 0.15 kilowatt hour. So, okay, I emphasize again, we must convert into hours and kilowatt respectively before we multiply them. So this is a mini summary. What if no power rating is given? Okay, instead, sometimes voltage, current, or resistance of the device is given instead. So what you need to do is just to calculate the power rating of the device using the electrical power formula. So depending on information, sometimes you're given the voltage and the current. Sometimes you're given the current and the resistance. Sometimes you're given the voltage and the resistance. And of course, then you need to convert again into kilowatt and proceed as normal. So a simple example. So right now is the device is plugged into 240 watts and has a resistance of 40 ohms and turned on for 30 minutes. So what's the amount of energy used? So in this case, the formula used should be V squared over R. And plug in the required values and you get 1440 watts. But remember, you need to convert to kilowatt. Then after that, you multiply by the 0.5, and in this case again, 30 minutes is not multiplied by 30, but multiplied by half an hour. So you get your value. Another way is to calculate the energy in joules first and then convert it back into kilowatt hour. So the formula for energy is either VI multiplied by time, okay, I square R multiplied by time, or V squared over R multiplied by time. And we also need to know how to convert joules to kilowatt hour. 1 joules is simply just 1 watt times 1 second, so it's 1 watt seconds. And 1 kilowatt hour is 1000 watt multiplied by 1 hour, which is converted to seconds, is 60 minutes multiplied by 60. So you have 3600 seconds. And so you find that 1 kilowatt hour, the conversion is roughly about 3.6 million watt per second, or in this case actually this is actually just joules. So using the same example, using a formula 240 divided by 40, okay, this was your V square over R. But this time around you need to multiply time, but the time has to be in seconds. So this time around 30 minutes times 60 seconds. So this is the amount of energy that you get. So by knowing that 1 kilowatt hour is actually 3.6 million joules, you just do a ratio and divide. So you find that you get exactly back the same thing. Okay, 0.72 kilowatt hour. Generally, the first method will be easier, but sometimes the question may require you to present your answer in joules first. So therefore, you need to do the second method. Okay, but generally the first method would be preferred. Just a short one, calculating cost of usage. It's quite straightforward, as usually the cost of 1 kilowatt hour of electricity is given. So for example, in this case, 1 kilowatt hour is roughly 0.241. Okay. So sometimes the question could be calculate the cost of turning on the air conditioner rated for 8 hours every day for 30 days. So energy use, same thing, you use kilowatt, you use hours, but in this case, for 30 days. So total is 240 hours, and this is 360 kilowatt hour. And the monthly cost will be just multiplied by the number, and you get this cost. So it means that it is actually quite expensive to turn on the air condition every night for 8 hours. That's all for today's lesson.
Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.